Alright, hi. Today I will be talking about remote sensing and GIS within paleontology. What is remote sensing, and what does GIS have to do with that? Remote sensing is defined as the science, and to some extent art, of acquiring information about the Earth's surface without actually being in contact with it. In this video, I will be discussing GIS specifically, but also remote sensing and other ways it can be applied to paleontology. For now, I will start by focusing on GIS. GIS stands for Geographical Information Systems. It is a system that creates, manages, analyzes, and maps all kinds of data. It has thousands of purposes, but in this video I will be talking about the way that GIS and remote sensing can be used in paleontology by detecting fossil sites. So, why and how? Many different articles and sources would agree that finding fossil sites and remote potential fossil locations is time-consuming and costly. A program within GIS, known as suitability analysis, is used throughout different studies to come up with a model that digitally predicts fossil site locations accurately, saving this time, money, and labor. Here are some examples of this application of the program. One test of using predictive modeling of fossil locations in the Elliott Formation in South Africa. Another thesis tested a predictive GIS model in two known fossil locations in the West Coast Fossil Park in South Africa and in Utah. One article published in 2005 and revised in 2007 explains the process well and outlines the methods used to conduct the analysis successfully. This article is by Catherine B. Oheim and known as Fossil Site Prediction Using Geographical Information Systems and Suitability Analysis. I'm going to argue later on in my video that this was actually like the setup for future suitability analysis models. And while the point of the other articles I mentioned was to apply the predictive model, the point of this article that was written years earlier was to actually determine whether or not the process, the suitability analysis, is actually able to predict fossil locations. So, suitability analysis, what is it? It is a mapping technique and process that will return a score based on a weighted criteria. That score will represent how suitable an area is for something. And what is that something? The ArcGIS website from Esri gives a few examples of commonly used applications of suitability analysis to business tasks. But like I mentioned before, this case of suitability analysis was used to predict fossil locations, and Catherine B. Oheim's article applies specifically to the Two Medicine Formation in Montana. The first part of the process of using this GIS technology was to overlay the data layers in the software. The data layer sources can be found in this table. The data is then sorted into factors that were used in the process. The factors were geology, vegetation cover, elevation, and distance from roads. This type of overlay analysis is mainly used to find obvious relationships between the data layer or to find data error. At this point in the analysis, the data is visual, not quantitative. The next step would be to conduct the quantitative part of the suitability analysis, where each type of data was weighted based on this formula. According to the article, the resulting data layer was a grid with scores between 8.8 and 16, where 8.8 was the least likely to contain fossils and 16 was the most likely. So to answer your burning question, did it work? Short answer, yes. According to Oheim, although there were some areas for revision, the fieldwork in the site proved that the GIS model correctly labeled a fossil site likely to contain fossils, though they would have otherwise labeled as less likely. Other sources expand on GIS and apply remote sensing to the process. The addition of free public Landsat imagery also changed the game. Landsat imagery provided mid to high resolution images for mapping and visualization. The entire archive was available to the public by 2009, and the study that I will examine next used these to predict fossil sites. The scholar Dmitry V. Malikov used remote sensing to detect fossil sites in Kazakhstan, more precisely in a different way than Catherine B. Oheim's project. He discussed her project and mentioned that while her project identified potential fossil locations, Malikov et al.'s project used spectral parameters taken from Landsat imagery for a more precise determination rather than an indeterminate prospect effort. So, what was it all about? Malikov's project is an application of remote sensing because of the use of satellite imaging, particularly from the Landsat satellite, specifically Landsat ETM+. In this project, he developed a spectral library to characterize the sediment. Doing so, paleontologists would be able to identify strata that are potential fossil sites. Beyond looking for a more precise determination of these fossil sites, Oheim's model didn't quite work with this test location, due to the lack of a complete dataset of environmental conditions. This is because of the remote and poorly developed area. Either way, both models were successful in their locations, and these studies have been a cornerstone of the world of remote sensing in GIS and paleontology. Many other, more modern models of suitability analysis, like the ones I previously discussed, Landsat imaging based model and methods upon these two different studies. Remote sensing is changing the way paleontologists predict fossil locations. It saves precious labor, time, and money.